We're going to go over surface area and volume of prisms and pyramids. So there's a lot of information we have to go through today. And the volume formulas for a prism and the volume formula for a pyramid are written as below. So for a prism, the volume of any prism is the area of the base times the height of the prism. The volume for a pyramid is the area of the base times the height of the pyramid multiplied by a third, or divided by 3, whichever you're more comfortable with. So, when looking at them, in order to figure out what the area of a base is, the base of any prism, and this looks very different for a prism, but the cylinder copies the exact same rule, okay? And prisms, we have square face prisms, rectangular face prisms, triangular face prisms. This cylinder follows the exact same rule as in the base. We find the area of this base and multiply it by the height, and that is the volume of this prism, or in this case, the cylinder. Okay. So as long as we know what the base is, if it was a square face base, okay, we would find the area of the base and multiply it by the height. If it was triangular faced, okay, we would find the area of the face and multiply it by the height. That's the volume. For a volume of a pyramid, this is a triangular based pyramid. We choose what we want to be the base in a triangular based pyramid. Now, if it was a square based pyramid, then the base is obviously the square at the bottom. Okay? But when we refer to the height of the object, we're talking about from the peak of the pyramid down to the base, and it will make a right angle with that base. Okay? And that's very specific. And we'll get into more examples, probably using square based ones. But I want you guys to realize that whatever that peak is, we have to be 90 degrees from the base to be considered the height of the pyramid. Okay. So let's go through 2 examples, and we'll still also have to go through surface area on top. Okay, so here is our rectangular based pyramid. It's rectangular base because it's not quite a square. We have the distance of 8 here. We're not entirely sure what this base is. This 10 is pointing to this line here. Okay, maybe I should make that a little clearer. But the 10 centimeters is referring to the distance up this triangle. Now, in order to find the volume, we need to find our area of our base, okay? And we also got to find the height of this triangle. And in this case, actually, should be specific and write this in, but this is square-based. So all of these sides are the same. Okay? So we know the base in this case is 8 times 8, right? Because all the sides are the same here. So this is our base. So we need to find the area of this base to start. So I'll rewrite that formula for our pyramid below. The volume formula for a pyramid is a third. I'm just going to call it area of base times the height. Okay? The area of the base, well, it's going to be 8 times 8 in this case. So we're going to plug that value in. 1/3, 8 times 8. How else could I rewrite 8 times 8? That's right. So let's write it as that instead. Okay. So the area of the base is 8 squared. Now, what we got to find is the height of this. And this is a little more difficult here because the height is technically from the peak of the pyramid downwards, and it's got to make a right angle. Okay. Now, because this is making a right angle here, and this is a square-based pyramid, what that means is all of these sides of these triangles, I'll double dash them, are technically the same distances. This is the exact middle, in fact. So we can use Pythagoras Theorem by creating a right angle triangle inside the pyramid to find the height. Okay? That's because we have a square-based pyramid here. So the distance, since the absolute middle would be exactly half of one of the bases, what would the distance from here to here? Good. So we're looking at 4 centimeters. And the hypotenuse of this triangle is what? 10. So we're going to use Pythagoras Theorem to find the height. And we'll have to reverse our Pythagoras Theorem for this. So we're going to do it on the side. Our c squared is equal to a squared plus b squared. Okay. Our c in this case is the value of 10. So it's 10 squared, because 10 is the hypotenuse of this triangle. We'll call A our 4. And B is our unknown, so we'll replace it with H, because H is the height we need to find. What is 10 squared? Okay. And 4 squared? Good. And H squared? H squared. I don't really know. To isolate H, what do we have to do? That's right. Let's move 16 to the other side, so it becomes subtracted by 16 is equal to H squared. What does that become? 84. Very good. Are we done? That's right. To move this over, we need the root of 84. Our height, 84 square root. 9.2. Sure. Let's go with 9.2. Oops. 9.2. So we're going to replace our height with 9.2. So 1/3 times 8 squared times, I'll write it in red here, 9.2 is equal to the volume of this pyramid. We're going to work that all out on our calculator here. 8 squared is 64 times 9.2. And then we could just divide by 3 or multiply by 1/3. It's the exact same thing. Okay? So let's divide by 3 in this case. 196.3.
What was it?
196.3. Okay? And did I give a measurement? Centimeters. So because it's volume, it is centimeters cubed. It's 3-dimensional. Very good. The next thing we want to go through is volume of a prism. Okay? And this is a prism. A prism has rectangular sides to it, but is named by the face. Okay. A pyramid does not have these lengthy rectangular sides to it. So our face or our base are the same thing in this case. That was a great rhyme. Our base here is the triangle. Okay? And we know for a prism, we said that the formula for the volume of the prism was the area of the base times the height. Simple as that. Do we have the height?
No.
I'm pretty sure we do.
Three.
It's the height of the prism, not the face. This is the height of this prism. Now we're to turn it on its end. Okay? So because that's the height, we're going to replace the height with the number 12. Now the area of the base is what we have to find out. And how do we find the area of a triangle? Half times base times height. Now, we have the base of this triangle. We know it's 3. So we have a half times 3. What is the height of this triangle?
12.
Definitely not 12. It's an unknown factor, the height of this triangle. Okay? Now, they've given us some measurements of the other sides of the triangle, and I'll bring them down so you can see it. This side is technically 3 centimeters, and this side is technically 3 centimeters. Okay? I can make a right angle triangle. The height has to make a perpendicular line with the base. So I've now created a right angle triangle, and I'll duplicate it over here so that you guys can see. With this information, we know this is 3 centimeters. How far is it from here to here?
1.5.
Yes, it's half of 3, so it's 1.5 centimeters. And the height is our unknown. So we're going to use Pythagoras Theorem again to solve for the height. Again, our c in this case, so we'll have c squared is equal to a squared plus b squared. Our c is our hypotenuse, which is 3. We'll call our a our 1.5. And our b is our height, so we'll replace it with h. What is 3 squared? What is 1.5 squared? 2.25. And what's h squared? Yeah, h squared, or unknown. Again, to isolate h, what do we do? That's right.
Over changing it to a negative.
Perfect. What is our 9 subtract this value? 6.75. And finally, are we done? Square root of this value is 2.6. So, the height of our triangle in here is 2.6. So I'm going to replace the height in the area formula. So we have 1/2 times 3 times 2.6. And this is the area of the base, or the area of our triangle. So we take our 2.6 times 3 divided by 2. We divide by 2 because we multiply by 1/2. It's the same thing. And the area is 3.9 centimeters squared. Are we done?
No.
What was the whole point of this?
It's in the area.
Area of the base. And what did we just say it was? Good. So we take that and we plug it in for the area of the base. 3.9. So to find the volume, the area of the base is 3.9 centimeters squared times our 12 centimeters squared.
46 centimeters.
We get 46.8 centimeters cubed. Excellent. So we just did a pyramid and a prism. Volume